Hello, hi everyone. Welcome to the Student Brand. This is your Shiva sir. Hello, hi everyone. Welcome to the Student Brand. This is your Shiva sir. Today topic is magnetic effects of electric current. Magnetic effects of electric current. Okay. So, what is magnet? Magnet is a substance which has the attractive or repulsive property. Okay, magnetic effects of electric current. Magnetic effects of electric current. Okay, magnetic effects of electric current. Electric current. Magnetic effects of electric current. So now we will discuss about this topic. Okay, so when you drop the magnet, so the magnet will attract the magnetic materials. There are two types of magnets. One is artificial magnets, another one is natural magnets. Magnetite. Magnetite is a natural magnet. Magnetite or lodestone. Lodestone. Magnetite or lodestone is a natural magnet which occurs from earth crust. Okay. Artificial magnet. Artificial magnets are bar magnet, U-shaped magnet, dumbbell-shaped magnet, cylindrical magnet. These are artificial magnets. Okay, these are man-made magnets or artificial magnets. Naturally occurs from earth crust. That is called natural magnet. Okay, example magnetite, which occurs magnetite. Okay, so our lodestone, that is a natural magnet. Okay, so magnet has properties. The properties of the magnet, what are those? If you drop the magnet, it will attract the magnetic materials. If you drop the magnet, it will attract the magnetic materials. Okay, and one more thing, the magnet will attract at the ends more compared to at the middle than at the middle. Okay, so if you drop the magnet, here I am considering the bar magnet. Here I am taking the bar magnet. I am considering the bar magnet. Okay, so magnet has two properties. One is attractive property, another one is directive property. If you drop the magnet, then automatically, okay, into the sand. If you drop the magnet into the sand, it will attract the magnetic materials. Okay, so magnetic materials will be attracted at the ends than at the middle. Okay, at the ends. So magnet has two poles. North pole and south pole. Okay, magnet has two poles, north pole and south pole. So both poles have equal strength. Okay, so both poles have equal strength. They will attract equally. Okay, north pole and south pole, both poles. If you draw the magnet, so the magnetic material attracted at the ends of the, okay, at the poles of the bar magnet, right, than at the middle. And around the magnet, magnetic field will be there. Magnetic field will be there. Okay, the region around the magnet in which magnetic force exit. The region around the magnet in which magnetic force exit. Okay, so that is called magnetic field. The region around the magnet in which magnetic force exert is called magnetic field. Okay, so magnetic field will be in the form of field lines. Okay, so force will be there, right? So if you are taking one magnet, so I am taking this magnet. Though this is one magnet, This is one magnet, this is one magnet. If you place near to it, so around this one, around certain region, the magnet will attract the magnetic material or it influence the magnetic materials. So if you are slowly moving away from it, it won't attract. At certain region, at certain distance only, the magnet will attract the other magnetic materials or it influence. Okay, it influence the magnetic material up to a certain range only. So beyond the point, so above, more than that point, more than that region, if you take the magnetic materials, so the magnet will not attract. Magnet cannot influence the magnetic materials. So the region around the magnet in which magnetic force exerted is called magnetic field, and the magnetic field will be in the form of field lines. Magnetic field will be in the form of field lines. Okay, so field lines. So here I am taking the bar magnet. Okay, I am taking the bar magnet. Here you can see this is a bar magnet. This is a bar magnet. This is a north pole and south pole. North pole and south pole. Around the magnet, the magnetic field will be there. If you sprinkle the magnetic materials, if you sprinkle iron particles, okay, so take a sheet of white paper, so a white A4 size sheet. So place the magnet at the center. So sprinkle the iron particles. So you place, so that paper must be placed on the table. Then you can gently tap the table. Then the magnetic metals will align in the form of magnetic field lines. Okay, around the magnet, the sprinkled iron particles will be formed or aligned in the form of magnetic field lines. Okay, so around it will be formed like a magnetic field lines. And the magnetic field lines start from north, ends at south. Okay, outside of the bar magnet, the magnetic field lines are north to south. Inside of the bar magnet, the magnetic field lines are from south to north. Okay, so here you can see this is a bar magnet. So magnetic field, so the region around the magnet in which magnetic force exert is called magnetic field, is called magnetic field. So here you can see 1, 2 and 1, 2, so you can take 3, 4, you can take like this. Okay, so 1, 2, 3, 4, 5, 6, 7, and here also 1, 2, 3, 4, 5, 6, 7. So you can take 7 or 9 like that. So the magnetic field direction outside of the bar magnet is from north to south. So from north it should leave and to south it should reach. Okay, so like this you can observe. So the direction must be there according to this. Okay, so from the north pole the magnetic field line should leave and to the south pole the magnetic field line should reach. Okay, so the region around the magnet in which magnetic force exert is called magnetic field. The magnetic field will be in the form of field lines. The magnetic field will be in the form of field lines. So point number 1. So properties of the magnetic field. Properties of the magnetic field. Point number 1. These are closed loops. Magnetic field lines are closed loops. So outside of the bar magnet, the magnetic field is north to south. Inside of the bar magnet is from south to north. So if you place this a bar magnet, if you place the compass over it, okay, so on the magnet, the direction of the magnetic field on the magnet, in the compass it will be shown. So inside of the bar magnet, the magnetic field will be south to north. Outside of the bar magnet, the magnetic field will be from north to south. Inside of the bar magnet, the magnetic field is south to north. Okay, very important, very important. Make sure that you are learning all these points. Okay, once again, magnetic field. Okay, the magnetic field is nothing but the region around the magnet in which magnetic force exert. The region around the magnet in which magnetic force exert is called magnetic field. Okay, so magnetic field will be outside of the bar magnet is from north to south, inside of the bar magnet is south to north. If you place the compass on magnet, then you can understand. Okay, if you place anywhere here you can observe the magnetic field direction. Magnetic field direction. How can you identify the free north pole of the magnet? Take a compass. The standard method to identify the magnetic field, use the compass. Compass, inside of the compass also magnetic needle will be there. Okay, magnetic needle, small magnetic needle. It always shows north and south direction. North and south direction. Okay, so exactly it won't show, somewhat tilted will be tilted. North and south, east and west. Okay, so this is the north, south and east, west. So it will be showing somewhat like this, somewhat tilted. Exactly it won't show, somewhat it will be tilted. So if you place the compass over it, automatically it can be shown direction of the magnetic field. Direction of the magnetic field. So if you place near to here, anywhere, automatically the compass will show, okay, this is north, this is north, this is south. Because so south and north will attract. North and south will attract. Two dissimilar poles will attract. Two similar poles will repel. Okay. So if I take north, north, repel, south, south will repel, north, south attract, south, north attract. So these two attract, and these two repel. Okay. These two repel. I hope it is very clear. North, south. So two dissimilar poles will attract. Two dissimilar poles. North and south, south and north will attract. North, north, repel. South, south, repel. Right? So this is very important. The magnetic field around the magnet will be in the form of field lines. How can you identify the field lines? By using compass. If you place the compass here, so you can place the compass here in this position, so it will show. Again, next position you can do, next position, and you can mark you can mark the position and observe those all the positions and join all those positions. You will get the free north pole direction of the free north pole. Okay, so if you place the magnet, if you suspend the magnet also, so if you suspend the compass, if you suspend the magnet, always it shows north and south. Always it shows north and south. Okay, so that is about magnetic field. So properties, coming to properties, once again I will explain. So first one, these are closed loops. Magnetic field lines are closed loops. Magnetic field lines are closed loops. These are never intersect. These lines never intersect. Closed loops. Closed loops. These lines never intersect. These lines never intersect. If it is intersect, so never intersect. Never intersect. If it is intersect, what happens? So at one position, at a time, at one point, so magnet, so compass should show two directions. At a time, compass cannot show two directions. It will show only north and south. Okay, north and south. So if these two lines will intersect, so here this is the direction of the magnetic field line, and this also magnetic field line directions. At a time it's not showing two directions. It is not possible. Compass cannot show two directions. Compass cannot show two directions at a time. How can you identify the magnetic field direction? Magnetic field direction, if you draw the tangent to the magnetic field line, you can identify the direction of the magnetic field at that particular point in the magnetic field. Okay, so to identify the direction of the magnetic field at that particular point, okay, if you want to identify the magnetic field direction if you want to identify, you have to place the compass, you have to draw the tangent, to the magnetic field line. If you draw the tangent, automatically So you can identify the direction of the magnetic field line like this. So and if you draw like this, so I keep on the direction of the magnetic field line changing. Okay, magnetic field is changing. Direction of the magnetic field at that particular point. If you draw the tangent to the magnetic field line, then automatically we can identify the direction. Okay. So and the next one more point. So magnetic field line start from north and reaches to south and end at south. Emerge out from north, merge at south. Magnetic field line emerge out from north and merge at south. Okay, that is outside of the bar magnet. So outside of the bar magnet, magnetic field is from north to south. Inside of the bar magnet, the magnetic field line is south to north. South to north. I hope it is very clear, right? Yes. That's enough. That is about magnetic field. Okay, magnetic field lines, properties of magnetic field lines, everything. Now we will discuss about so we know when the current is passing through the conductor, it acts as a magnet. So we already did in the earlier classes. So taking the iron nail, wrap the copper wire around it and connect to the battery or cell, then automatically it shows, it act as a magnet. It will attract the magnetic materials. Okay, that is called electromagnet. Electromagnet is nothing but when the current is passing through the conductor, it acts as a magnet. It shows the magnetic behavior. That is temporary magnet. When the current is passing, it acts. If you remove the current, it won't. Okay, na? So as soon as you remove the current, then automatically, so the magnetic behavior of the conductor will be gone. Right? Yes. Only when the current is passing through the conductor only, then it acts as a magnet. Those are called temporary magnets. So this will be helpful to lift the heavy objects, heavy iron sheets in industrial. So in industrial purpose, we will lift heavy objects. Okay. So iron objects we will lift by using electromagnets. Okay, temporarily if you pass the current, automatically conductor as a magnet, then it will attract, then it will lift from one position to automatically it will displace from one point to another point. So according to the requirement. Those are called electromagnets. Okay. So here also, if you are taking thick copper wire, current is passing through it. Okay. Right. So now we will discuss about. So I am taking this is a thick copper wire. This is a thick copper wire. Current is passing through it. Current is passing through it. So I am taking thick copper wire. This is thick copper wire. Okay, like this. So even straight conductor also we can say this is a straight conductor. So current magnetic field due to current carrying straight conductor. So I am taking like this. I am taking like this. So here we can take rheostat, variable resistance, and here switch. Can we connect switch here? Switch and battery. So we can take current is passing. So okay, current is passing through it. Like this I am taking. variable resistance, then current will changes according to that. So I'm connecting like this. Okay, so it is closed. Positive terminal, negative terminal, current is flowing. Current is flowing. Okay, so this is a thick copper wire. Thick copper wire. Thick copper wire. So I am taking the cardboard here. This is a cardboard. So I am taking the cardboard. If you place the compass, over here, you can see. So actually it is like a paper. Okay. So small paper. So I can say like this. So paper I'm taking like wait 1 minute. So this, if you take the cardboard, consider it is a cardboard. Okay. Now this is a thick copper wire. Suppose if you consider thick copper wire. So I am placing like this. Okay, like this. So you can observe here. Thick copper wire. So this is the cardboard. Suppose this is a cardboard. So over it, if you place the compass, okay, current is passing through it. Understood? If the current is passing through it, then it acts as a conductor. Anyway, this thick copper wire acts as a conductor. So I am placing compass over here. Okay. So if the current is passing, so this is the direction of the current. So because positive terminal is here, current is passing like this. Then automatically through this the current is passing. Then the deflection. There is a deflection in the compass. So it moves north, south, east, west. So deflection will be towards east direction. Deflection in the compass will be towards east direction. If you change the battery, automatically the current direction will be, if you change the battery, the current direction will be reverse. Then the deflection will be towards west. So by that we can understand one thing. If you change the direction of the current, automatically magnetic field direction also changes. So are you understanding? If you change the direction of the current, then automatically direction of the magnetic field also changes. That is one point. And second point is, so here you can see, if you place the compass near to the conductor, automatically deflection will be shown. So we can understand that there is a relation between current and magnetism. Hans Christian Ørsted, okay, suddenly observed that, so a compass is placed near a current carrying conductor got deflected. So that he given that relation. So what is that relation? Current and magnetism. There is a relation between current and magnetism. Okay. So if you place the compass near to the current carrying conductor, so automatically deflection will be shown in the compass. Right? Yes. And one more thing. So near to the conductor, the magnetic field will be more. So the magnetic field lines will be in the form of concentric circles. Concentric circles means like this. So around the conductor, the magnetic field lines will be there like this. Okay, like a closed loops. Completely circles like this. Those are called concentric circles. Around the conductor, the magnetic field lines will be in the form of concentric circles. Right? I hope it is very clear. Once again, so here you can see, this is a current carrying conductor. So it acts as a magnet. it acts as a magnet. If you place the compass near to that, automatically deflection will be shown in the compass. Deflection will be shown in the compass. Okay. So around the conductor, concentric circles will be there, like a magnetic field will be created around it. Okay. How can we identify the direction of the magnetic field? So here is the point. We know the current direction, current is passing like this, we know that. But how can you identify the magnetic field direction? Direction of the magnetic field. How can we identify? By using right hand thumb rule. By using right hand thumb rule, we can identify the direction of the magnetic field. Direction of the magnetic field. Okay. So if you take, if the current is passing like this, if the current is passing like this, okay, in this direction, so you have to place the thumb, along the current direction, curly fingers, wrapping fingers, okay, curly fingers, folding fingers, wrapping fingers shows the magnetic field direction. So thumb shows along the current direction, curly finger shows, folding finger shows the magnetic field direction. Right hand thumb rule. Okay. So this is my right hand. So this is the thumb. So that's my right hand thumb rule. So you have to place along the current direction, you have to place the thumb. Okay. So curly fingers, folding fingers, wrapping fingers shows the magnetic field direction. Okay. So if you take, so this the current direction is downward like this. So magnetic field will be like this. Magnetic field will be like this. Okay. So if in the case of clockwise and anti-clockwise, if you think clockwise and anti-clockwise, so if the current is passing towards me or towards the board like this, so curly fingers, folding fingers, wrapping fingers will be showing in the direction of clockwise direction. So if the current is moving towards you, then curly fingers, folding fingers in which direction? Anti-clockwise direction. Anti-clock. Okay na? So that is very very important. Very very important. Just you can check once. So this shows current direction. Current direction. So you have to place the thumb along the direction, and curly you have to fold the fingers. You have to fold the fingers along the finger direction. Magnetic field will be there. Along the folding fingers, along the curly fingers, folding fingers, along the direction, the magnetic field will be there. So towards the board, if the current is going, then the magnetic field will be like this. Okay, if you are taking like this towards you, so you have to place the curly fingers like this. Okay, anti-clockwise direction. Very very important. Very very important. So you have to follow that. You have to follow that. Understood? Once again I will explain briefly. Just observe this point. Point number 1. So when the current is passing through the conductor, it acts as a magnet. So magnetic behavior will be observed by the compass that is placed near to the conductor, current carrying conductor. So normally if you place near to the conductor, it won't show. So current must pass through that. Then it behaves as a magnet. So if you, as we discussed in the previous one, that is, so north pole, south pole, north pole, okay na? So there is a attraction or repulsion between the magnetic poles. Here also same thing. Here also same thing. Understood? So magnetic will be created. Automatically if you place the compass, then deflection will be shown. So according to the current direction, we can identify the magnetic field direction also. So we should know the current direction. If you know the current direction, automatically magnetic field direction we can get to know. How? By using right hand thumb rule. By using right hand thumb rule. So thumb you place along the direction of the current, and curly finger shows the magnetic field direction. Curly finger shows the magnetic field direction. Okay, this is the right hand thumb rule. Clear? I hope it is very clear. So here also, and one more thing you need to understand, one more important point. So very very important. So MCQ's point of view, assertion and reason point of view. So even in the question and answers also, this question will come. That is, so near to the conductor, the magnetic field will be more. magnetic field will be more. As you move away from the conductor, as you move away from the current carrying conductor, the magnetic field decreases. The magnetic field will be decreasing. So automatically it will decreases. Magnetic field is decreasing when it is moving away from the conductor. So when you move away from the conductor, automatically the magnetic field decreases. Near to the conductor, magnetic field will be more. Magnetic field will be more. So even if you are taking the straight conductor, around the straight conductor, the magnetic field will be in the form of concentric circles. Concentric circles. The magnet around the current carrying conductor. So the straight conductor. So here I am taking the straight conductor. Around the straight conductor, the magnetic field will be in the form of concentric circles. Okay. So by taking as a reference, around it the magnetic field will be there. So if the current is passing downward direction, now you say me the magnetic field. So now you can see current is passing downward direction. Curly fingers, folding fingers, wrapping fingers in which direction showing? It is showing like this. Understood? So like this, like that we can identify the magnetic field direction around the current carrying conductor. Okay. So if the current is passing through the conductor, automatically magnetic field will be generated, magnetic field will be created. So how can we identify that magnetic field? By using right hand thumb rule. Clear? I hope it is very clear, right? Next. So this is about straight conductor. Even, so one more point. So here only 3 questions are there. 3 questions. Question number one. If you change the current direction, will the magnetic field direction changes? Direction of the magnetic field changes or not? Yes, absolutely it will changes. If you change the current direction, automatically magnetic field direction also changes. So initially I am taking the current direction here. So magnetic field will be like this. If you change the current direction, automatically magnetic field direction also changing. So if you are taking like this, magnetic field will be like this. If you are taking like this, magnetic field will be like this. Automatically, if you change the current direction, magnetic field direction also changes. Point number 1. Coming to point number 2, near to the current carrying conductor, magnetic field will be more. That too, the magnetic field will be in the form of concentric circles. Like this, rings. And if you move away from the conductor, away from the current carrying conductor, the magnetic field is decreases. Automatically it is decreasing. So magnetic field will decreases if you move away from the conductor. Point number 2. And point number 3. Okay, if the current is passing from north to south, the deflection will be towards east. Okay, if the current is passing from north to south, the deflection of the deflection in the compass will be towards east. If the current is passing from south to north, the deflection will be towards west. Okay, towards west. So this is about current carrying. So magnetic field due to current carrying straight conductor. Magnetic field due to current carrying straight conductor. Okay. So if the current is passing in the conductor, so how the magnetic field will be identified? By using right hand thumb rule. Okay. So be careful. There are 2 questions. So it looks very simple. Sir. So, okay, sir, I understood. So I can take easily. So you said thumb along the direction of the current. So folding fingers, wrapping fingers, I will place. Then I can identify the direction of the magnetic field. It's very easy, very simple. But here is the point. So this is the conductor, right? Above the conductor they will ask. And below the conductor also they will ask. Now it is not that much easy, right? It's not that much easy in the exam. So how they will ask, So they will ask above the conductor how the direction of the magnetic field. Below the conductor, how the magnetic field direction? Then it will boom. That's enough. Understood? So by seeing the question, we will know. We can't get an idea. Then immediately we will, the entire night, so throughout the night you read, but in the exam hall, it will be empty, completely blank. Then how you'll think? So see the situation. It's very difficult, right? So like here also. So you're well aware of the concept. You're really very good in the concept. When you are applying in the exam hall, when you are applying to the question, then gone case. We can't get an idea. Really. So for that, what you have to do, you have to do number of questions. You have to practice number of questions related to this concept, especially right hand thumb rule. And one more thing, it will be there. That too, the next topic is current carrying conductor placed in the external magnetic field experience the force. So there also will use one more rule. By combining these two, then the questions will be outstanding. Really, by looking the question, we'll get super excited. Well, like the questions they will ask like this also, we will think. Will they ask questions like this also? In this way also? No. Like that type of questions they will ask. Really amazing questions. Okay. So I will let you know what type of questions they will ask, how to answer, and how we have to apply these concepts to the questions. Theory questions only they will ask. Really normal theory questions. Best example, I will tell one now. I will tell one example. You are standing in the middle of the room. Okay. So a parallel beam of electrons are moving from back end to forward, from your back to front. Okay, na? So you are facing towards north. Okay, electrons are moving from south to north. Okay, how can you identify the magnetic field direction? So this type of questions they will ask. Really amazing questions. Those type of questions really, so we have to imagine. So all these questions are related to our imagination. How you imagine, how best you imagine. Okay, na? So based on that one, we can able to identify, we can able to solve this type of questions. Now you can see, so just now I explained, near to the conductor magnetic field will be there, away from the conductor magnetic field will be less. Okay, as you move away from the conductor magnetic field will be decreasing. So near to the conductor the magnetic field will be more. So around the conductor the magnetic field will be in the form of concentric circles. If the current is passing from north to south, the deflection will be towards east. If the current is passing from south to north, the magnetic deflection will be towards west. Okay, so if the current is passing from south to north, suppose if the current is passing, so how the magnetic field will be? Magnetic field direction of the magnetic field. So east to west. If the current is passing from south to north, so east to west. If the current is passing from north to south, here you can observe, so like this, if you take, so board is a plane, if you consider board as a plane, then you can identify. So if I take this as a current carrying conductor, so along the thumb you are placing the current. Okay, so you are wrapping, you are curling fingers, okay, above the conductor like this, yes or no, above the conductor. Suppose I am taking like this. Suppose I am taking like this. Above the conductor, it will be clockwise or anti-clockwise? Above the conductor, it will be clockwise. Below the conductor, it will be anti-clockwise. Magnetic field direction. Magnetic field direction we need to understand. Above the, if the current is passing towards the board, from you to towards the board, current is passing, right? So above the conductor, just above the conductor, the magnetic field will be clockwise direction. Clockwise direction. Below the conductor, the magnetic field will be anti-clockwise direction. Below the conductor. At this point they are asking, right? So you'll think, okay, sir, this is a clockwise direction, no? Clockwise direction, that's enough, no? But they are asking above and below. So that you have to keep in mind. Okay, na? So in which direction it is moving, that you have to understand. And where they are asking especially, above the wire or below the wire. So that we have to understand. Okay, so be very clear. And north and south also, north and south. So we have to carefully read the question. We have to divide the question into parts. So you have to divide the question into parts. Then only you can understand. Then only you can understand. So without dividing the question into parts, so we can't understand, we can't able to justify the correct answer. We can't able to write the proper answer also. So what you have to do, you have to read the question carefully. You have to read twice. You have to read. If you are not understanding, read thrice. If you are not understanding, read 4 times. No problem. Instead of writing wrong answer, reading twice, thrice, it looks good. Okay? To hear also it looks good. What you have to do? So you can't do all these things in exam. Huh? What you have to do? You have to do before the exam. While you are practicing. While you are practicing also you have to do it. Okay? So that's enough. That is very, very important. So I just explained the right hand thumb rule. That's enough. I just to explain right hand thumb rule. Still few more points are there. So I took straight conductor only. Only straight conductor is like this. What about the circular loop? What about solenoid? Solenoid. After that, current carrying conductor placed in the external magnetic field experience the force. Fleming left hand rule. Combine these two. Combine these two rules also. They will ask questions. Okay, let's discuss. It's fine. So coming to that, very simple. If you focus on it, on the concepts, these questions are very, very easy. It looks amazing because everything is imaginary. Okay, so you have to imagine. If you imagine well related questions, so automatically you'll get correct answer. Okay, so I hope you got it. Now, so just imagine I'm taking the straight conductor. So I'm taking this conductor like this. Okay, so the current is passing like this. If the current is passing that, we know that magnetic field around it. Around the conductor, we know the magnetic field direction. Right? So above and below. Above and below. Okay. So if you take the circular loop, how it will be, you see. So here I am taking the circular loop. So I am taking like this circular loop. So current is passing, positive terminal, negative terminal. So current is passing like this. Okay. So so here you can see these are closed loops. So where the magnetic field will be more? Can you tell me where the magnetic field will be more? Can you let me know, anyone? Where the magnetic field will be more? Where the magnetic field will be more? Where it will be? At the center or at the circumference? At the center or circumference? So where magnetic field is more magnetic field will be. where? At the center or at the circumstance? So at the center. So how it is? So now you can see. So here you can observe the current is passing like this. So current is like this, reaching. So like this. So magnetic field will be inward. So here it is outward, outward, outward. So here it is outward, outward, outward. If it is moving away, that is north. It is reaching to this point, that is south. Okay, south. And here you can see. So it is moving away, 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 reaching, reaching, reaching. Like this you can observe. So here you can observe, if the magnetic field is keep on moving, keep on moving, keep on moving, it will become parallel lines here. So at the center, it will become parallel lines. At the center, it will become parallel lines. Okay, na? Then automatically, so this magnetic field will be joined to the next magnetic field, next magnetic field, next magnetic field. So it will become uniform magnetic field. Then here more magnetic field than at the circumstance. At the center, in the loop, sorry, at the center, magnetic field will be more than at the circumstance. So they will ask one question. So here keep on changing. Okay now. So the loops are keep on increasing like this, like this, like this. So here exactly at the center, these lines become parallel lines. This become lines parallel lines. See, even I said in the bar magnet, you can observe north and south. If you are taking keep on, the magnetic field lines are coming like this, it will become parallel here. It will become parallel. So here also, if you keep on, the magnetic field is like this, then at the center, the magnetic field will be uniform. Okay. So this magnetic field will be aligned. So this magnetic field aligned to the next magnetic field will be aligned. Then it will become uniform magnetic field. So because parallel lines are there, no? So at the center, the magnetic field will be more than at the circumstance. Okay. So very, very important. Definitely see this type of question. Last time, straight conductor, they asked for 3 marks. So just now I explained the current carrying through straight conductor. Okay, na? Magnetic field is due to current carrying through straight conductor. Okay, that question for 3 marks. This question also 3 marks. In this also they will ask about assertion and reasoning and MCQs questions and directly 3 marks question. Okay, so this is very, very important. Make sure that you can. So current is passing like this. So as I mentioned, through the right hand thumb rule, by using right hand thumb rule, we can identify the magnetic field direction. By using right hand thumb rule, we can identify the magnetic field direction. So see, sometimes what they will do, so students are writing exam, no? Sometimes they are writing with this hand, they will place the hand, they'll think this is the conductor, so they'll place like this. By using this one, they will do with the left hand. Then they will get wrong. Okay, now sometimes they will get wrong. So use the right hand thumb rule itself. So place the pen down, use the right hand. Sometimes they will use the left hand and get wrong answers. Okay, so unconsciously, not consciously, unconsciously they will do that. So they'll get wrong answers. Okay, so use right hand thumb rule. See the direction of the current. Place the right hand along the direction of the current and wrap the fingers, wrapping finger. As I said, imagination. It's very, very important. You have to use your imagination. So in which direction current passing? So you have to place thumb along the direction and fold the curly fingers. Along the folding fingers, curly fingers. So the magnetic field direction will be there. That's enough. If you divide the question into parts wise, as I mentioned earlier, you have to divide the question into parts and read individually. So check each and every statement, each and every line. Then follow the instructions carefully and observe all the parts. Then do that. Then you will get the answer. Okay. So, okay, fine. Now. So if you like the content, if you like the explanation, do like, share and subscribe to Student the Brand, and go for super chat, super thanks, and membership also is available. So go for super thanks, super chat and membership to the channel. So if you like the content, if you like the explanation, please do like, share and subscribe to Student the Brand. So share to your friends, ask your friends to join to the class, inform to everyone physics class is going on. Just please click on like button, then automatically I can reach to the more students. Okay, done. Next one. Now next one we are going to the one more. We are going to the one more, that is so loop completed. Then we'll go to the solenoid. Solenoid. Okay. So I'll explain about solenoid. Just check once. So I am taking the solenoid like this. So you can take this circuit near to the solenoid. So take a straight copper wire. Take a straight copper wire. Wrap in the form of cylindrical shape. Insulated copper wire. Insulated copper wire. Wrap in the form of cylindrical shape. Connect to the circuit. Connect to the circuit. It acts as a magnet. So that is called solenoid. Okay, so I am connecting this one. So near to the circuit. So like this. So here it is very important. I am connecting the circuit here like this. So battery, positive terminal, negative terminal, switch, current is passing like this. Okay. So how we have to take the magnetic field? How we have to consider the magnetic field? Observe here. So we can take 5 lines, 1, 2, 3, 4, 5, or you can take 7 lines also, 6, 7, or you can take 9 lines also, 3 lines above, 3 lines below, 3 lines middle. Okay, so I am taking 9 lines, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are 9 lines. Yes or no? 9 lines. What you have to do? First you have to join 3 lines above. Okay, 3 lines below and the 3 lines at the middle. So those lines you can draw like this. So I am joining like this, 1, next one 2, next one 3. Okay, again, so here over like this, 1, 2, 3, and here you can take so that is a solenoid. Okay, now you can observe here. So if the current is passing to this end, if the current is passing to the end, if this current is passing to the end, automatically magnetic field will reach to this one. Then that is south pole. This is south. And if the current is leaving to this end, from this end, okay, so automatically, so it is reaching like this. Okay, like this. So this is north pole. So from north pole to south pole, the magnetic field direction you have to draw like this. North pole direction like this. Okay. So I hope it is very clear. Observe carefully here. So the magnetic field direction from north to south. So above north to south, below also from north to south. And inside, so you have to take, observe here, inside like this. Okay. And inside of the magnetic field will be like this. Inside south to north. South to north. Outside north to south. Okay, so I hope it is very clear. So I hope it is very clear. Right? Yes. Check once. Check once. Magnetic field will be emerging out from north to south and merging. So emerging out from north, merging at south, or inside of the magnet, inside of the solenoid is south to north. South to north. Understood or not? Understood or not? So you have to observe this is the positive terminal. So in this direction current is passing, so the magnetic field also moving in the direction that is south. So and here the current is emerging, current is coming out from this side. So magnetic field also should leave from this side. Then you will get it. Okay, solenoid. So a straight copper wire, insulated copper wire, a straight copper wire. Okay, so wrap, insulated copper wire wrap in the form of cylindrical shape and connect to the circuit. And connect to the circuit, current is passing. Then it acts as a magnet. So the properties of the solenoid and magnet both are same. So the properties of the solenoid and magnet, bar magnet, both are same. So it acts as a magnet, magnetic field will be created. But here the difference is, this is electromagnet. So how much of, whenever you send the current, that time only, during that time only it acts as a magnet. If you remove the current, if you remove the battery, automatically it does not act as a magnet. But bar magnet, that is a natural magnet. If you break it, if you divide into pieces, if you break into pieces, many pieces, still one among all those pieces will act as a magnet. Okay, still a single piece also from the natural bar magnet, it acts as a magnet. Okay, so here if you remove the current, if you remove the battery, so it will not act as a magnet. So and one more thing, a bar magnet, artificial magnets. So if you take artificial magnet, so we can't. So normally artificial bar magnet, we can't increase the magnetic field. We can't increase the magnetic field. Here we can able to increase by sending the. If you add more number of cells, then current is increasing. Automatically magnetic field also increases. Here, point number 1, by increasing strength of current, by increasing number of loops, we can able to increase the magnetic field. What is electromagnet? So electromagnet is nothing but when the current is passing through the conductor, then it acts as a magnet. So in earlier classes 6 or 7, so we did experiment taking the iron nail, wrap the copper wire, wrap in the form of cylinder, wrap around the iron nail and connect to the battery, it acts as a magnet. That all I am saying, electromagnet. Current carrying conductor act as a magnet, that is called electromagnet. I hope it is very clear, right? Yes, if you like the content, if you like the channel, so do like, share, and subscribe to Student the Brand. Share to your friends. Ask your friends to join to the class. Extraordinary concepts are going on. Okay, so in-depth explanation will be there. Okay, done. Come to the point. So that's enough. This is about solenoid. So here, by increasing strength of current, by increasing number of loops, if you increase the number of loops, automatically magnetic field also increases. So if you take the bar magnet, if you see the bar magnet, okay, so we can't increase the magnetic field here. Okay, magnetic field is fixed. Here magnetic field is vary. So according to the, as I said, strength of current, number of loops, and the air gap, if it is air gap, so the gap between the rings it is increases automatically. So magnetic field also increases. Okay, so it depends. And one more thing, here we can't change the poles. So North Pole, South Pole are there, right? So North Pole, South Pole. So we can't change the poles. Here we can able to change the poles. As I said in the previous class, in the previous topic, if you change the polarities of the battery, if you change the current direction, automatically magnetic field direction also changes. So here you can change, if you change the battery direction, automatically magnetic field direction also changes. Magnetic field direction also changes. Understood or not? So like that. So if you change this one, automatically remaining magnetic field direction also changes. I hope it is very clear. Okay, so we can observe. So here you can see, so like that, so like that. So I hope you understood. If you change the polarities of the battery, directions of the battery, or direction of the current, automatically magnetic field direction also changes, or magnetic field also changes. By that we can change the, what are those poles? So North Pole, South Pole, South Pole, North Pole, like that. Understood or not? This is about solenoid. Now we will discuss about current carrying conductor placed in the external magnetic field experience the force. Current carrying conductor placed in the external magnetic field experience the force. Very very important, 5 marks question. So sometimes 3 marks question. Okay, so expected question. So I'll explain, just check once. Current carrying conductor placed in the external magnetic field experience the force. Experience the force. Okay, so now, so as I mentioned earlier, there are artificial magnets. Artificial magnets, those are, what are the artificial magnets? U-shaped magnet, bar magnet, dumbbell shaped magnet, like that. Okay, so and next one, next one. భయ్యా మనకంతా తెలుసు, మనం హైదరాబాద్, మన హైదరాబాద్ నుంచే. ఓకేనా, సో మనం ఇక్కడే ఉంటున్నాం, ఇక్కడే చేస్తున్నాం అనమాట లైవ్ క్లాస్. ఓకేనా, తెలుసు కదా మనకి, ఇంకేంటి మరి. సో నాకు తెలిసి ఈ వర్డ్తో నీకు అన్ని ఆన్సర్స్ వచ్చి ఉంటాయి. నువ్వు అడిగే క్వశ్చన్స్ అన్నిటికీ ఆన్సర్స్ వచ్చి ఉంటాయి. ఏమంటావు? ఓకేనా, కంటిన్యూ చేద్దాం క్లాసు. దాని నుంచి క్వశ్చన్స్ అడుగుతున్నావు కదా. Okay, done. Come to the point. So now we will discuss about a current carrying conductor placed in the external magnetic field experience the force. Okay, so here you can see. ఓకేనా? So please do like, share and subscribe my channel. Share to your friends, ask your friends to join to the class. So once check my video, there are many videos are there related to physics. So CBSE grade 10 and so NEET students problems are there, from JE students also. Topics are there, just check once. Okay. Now you can see here. So positive terminal, negative terminal, positive terminal, negative terminal, terminal. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. ఇంకేంటి మరి ఆలస్యం, లైక్ కొట్టు, షేర్ చేయి. సో దోస్తుగాల్ని పిలువు మరి. Okay, so I am taking this the conductor. This is the conductor. This is the conductor. This is the magnetic field. Okay, external magnetic field. U-shaped horseshoe magnet, we can say horseshoe magnet. So this is the current carrying conductor placed in the external magnetic field. So it experiences the force. Okay, so this conductor will move. In which direction that conductor will move? So I have that question. So in which direction the current carrying conductor placed in the external magnetic field experience the force? We know that. Yes or no? We know that. Yes, we know that. Then you can say in which direction the force will act. So by using Fleming's left hand rule. Fleming's left hand rule. Use the Fleming left hand rule. Magnetic field, current direction and force. Fleming's left hand rule. Okay na? Mother, father, child rule. Magnetic field, force, magnetic field M, force F and current C. Okay na? Mother, father, child rule. So here you can see magnetic field. So this is fixed. Magnetic field is fixed. Current also fixed. Where F will go? If you stretch these three fingers perpendicular to each other, stretch the left hand of thumb finger, index finger, middle finger perpendicular to each other. Okay na? So perpendicular to each other. Then thumb, index finger shows magnetic field direction. Index finger shows the magnetic field direction. So middle finger shows the current direction. Second finger shows the current direction. Okay, so you have to place like this. Magnetic field, current direction, thumb. So force acting on the conductor. Thumb represents force acting on the conductor. Are you understanding? And once again, ready? Magnetic field, current, force. magnetic field, current, force. Magnetic field is fixed. Current, we know that. So automatically thumb we can identify. In which direction the force will act on it. Okay. So by placing like this, so in which direction the thumb is showing, along the direction the force will act on the conductor. Along the direction the force will act on the conductor. I hope it is very clear, right? So this is about Fleming's left hand rule. Fleming's left hand rule. Okay, so I hope it is very clear. Next one, short circuit. Yeah, that also short circuit. Short circuit. Short circuit. Short circuit is nothing but the direct contact of live or neutral takes place. Okay, suddenly sometimes the insulation may tone, then direct contact of live or neutral takes place. Then heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains. It may lead to the fire in the building. Okay, so that is point number 1. Coming to overloading. Overloading. So high voltage appliances. Too many appliances connect at a time to the circuit, or high voltage appliances on at a time in the circuit, then heavy amount of current will be drawn from the mains. Okay, it may lead to the short circuit. Then insulation may tone, then direct contact takes place, then fire will occurs in the building. Okay, so I hope it is very clear. Understood? So this is about, what is one? Overloading, short circuit, magnetic effects of electric current. What is the definition of the topic name? By passing the electric current, a magnetic field will be created. Magnetic properties will be exhibited. Okay, so magnetic effects of electric current. If you send the electric current through the conductor, it behaves, it shows magnetic properties. Okay, so this is about the chapter. I hope you like it. So if you like the content, if you like the channel, if you like the explanation, please do like, share and subscribe to Student Brand. So if you want to go for super thanks, super chat, okay, and if you want to go for a membership, okay, and if you like this video, if you like my explanation, if you like the content, so please do like, share and subscribe and share to your friends. Ask your friends to join to the class. Inform to everyone. Okay. So if you need any physics classes, right from 6th to 12th, okay, all the classes. So not only physics subject, remaining subjects also. Okay, na maths, biology, social, English. Likewise. Okay. So likewise are there. So if you want, you can contact to this number. And it's my request to everyone. Okay. So by using compass, we can identify the positive or negative, north pole or south pole. Okay. So battery will be having positive, negative. Solenoid having north pole and south pole. Okay, done. And so based on this one, few more questions will be discussing. Okay, again when I'm explaining this topic, so we'll discuss more concepts. So yes, I am saying, so remaining subject if you want, from 6th to 12th, so JEE and NEET, and 6th, 7th, 8th, 9th, 10th, and the remaining subjects also, not only physics, remaining subjects. If you want, you can contact to this number 98498 to that number you can contact, then you'll get all the details. Okay, so notes also I have written, so my handwritten notes is available, so with low cost. Okay, so I only written with my own hand. Okay, so this is the preview of the electric current notes, so you can check here. So with own hand I have written, so you can check. Okay, like this. Okay, so just check once. If you want the notes, then definitely the low cost will be provided. Okay, and if you like the content, please support my channel, encourage the channel, so share to everyone, inform to everyone, so try to ask them to join to the class. Okay, so thank you so much for supporting me, thank you so much for subscribing. So with your support only I can reach to the maximum students. So with your support, definitely without your support I can't reach to the maximum number of students. If this content is helpful for the students, if you think, so please share to everyone, inform to everyone, ask your friends to join to the class, and you can share my physics videos in the channel, so you can check those videos. Once you check the videos, if you like it, if you like the content, if you like the channel, if you like the explanation, you can share to your friends. Okay, inform to everyone and inform in your groups also. And so first you be the first person to like, share and subscribe, then automatically you'll get updates regarding the live classes. Thank you so much for joining. So we'll end the class today. So I'll continue with a new topic around 9:30 like that, so you can join to the class. Thank you so much. See you.